To maintain flexibility and quality control, Atlas slits its own coils to size based on the pile diameter to be run during a particular shift. Once they're slit, the coils are loaded onto the tube forming line. Once 5 forming rolls work like rolling pins to shape the welded steel strip into a curve. Each one bevels the pipe a bit deeper until the flat pipe takes on a U shape, about 70% of its finished shape. You can see they're the brightest spot in the factory, thanks to the continuous polishing effect. These rollers can be changed out quickly to run piles of different diameter or steel gauge, enabling our team to complete a drop-in rolling for customers.
And so we have an extra set, so when we pull those out, we just put the new ones in, swap them out. You can see how it rolls around, the strip rolls around, and we've got a welder, a submerged arc welder inside the pipe, and then there's one downstream here on the outside of the pipe. So we're putting 2 welds on it, and it's a submerged arc process, meaning that the arc is submerged in a pool of flux. So it's a very clean, quiet welding process. You can stand right in front of it, you can look at it, you can watch it without worrying about burning.
With an urgent need. Finally, the rolling presses change from convex to concave and gradually push the ends together, making sure they line up evenly. The straight-seamed pipe piles are welded utilizing electric resistance welding. Abbreviated as ERW, this welding process utilizes 2 copper contact shoes to pass electrical current through the strip edges of the coil. Resistance to that flow of electricity causes heat to build up in the strip. The heat zone can reach 2,700 degrees Fahrenheit, all while the line is running at speeds of up to 120 feet per minute. The result is a continuous longitudinal weld with pinpoint accuracy, and the pipe is ready for finishing.
Here. This is a good shot of the weld. You can see the submerged arc weld gives you a nice, smooth, consistent weld. This particular material is 1/2 inch wall thickness.
piles undergo two destructive tests. The cone test tests the integrity of the weld by forcing a hydraulic press until the test piece fails or is expanded to a predetermined amount, without failure of the ERW weld seam. Flatness testing involves flattening a sample with a weld at the vertical and horizontal axis, or 0 and 90 degrees to the direction of force. This test verifies weld integrity and the ductility of the steel welded seam is complete. The pile moves on to ultrasonic testing. This test checks the integrity of the electric resistance weld and detects the presence of any internal flaws. Any defections are automatically cut out and part of the Atlas 100% quality.
Welder controls and the seam roll controls are on this panel. You have an operator up here that basically controls the operation of the mill and the direction of the pipe. You got a camera on the ID welder and a camera on the OD welder, and the position of the weld is controlled with this joystick. You line up the crosshairs on the center of the weld, and that directs the weld.
Every Atlas pipe pile is barcoded and given an original mill test report, or MTR, from the producing mill. All Atlas MTRs are backed by coil certificates from our steel supplier, which are reviewed before the coils are shipped to our plant.